Okay, 5.3 notes continuity, increasing, and decreasing. We're going to identify if a graph is increasing, decreasing, or constant, and we're going to prove if a graph is continuous at a point. So a graph is considered to be increasing if the y value is increasing inside an x interval. So notice here the y values are increasing. In fact, this whole graph is increasing. Not at the same rate, but it is increasing everywhere. A graph is considered decreasing if the y value is decreasing within an x interval. So notice it's decreasing along all of these values here, but at different rates. And then a graph is considered constant if the y value is staying the same within an x interval. So we're going to state the interval. The graph is increasing, decreasing, or constant. You're going to always want to start on the left side of the graph and move your way to the right because that's how you read graphs, left to right. So notice that this is going down, 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 down forever. But notice it's also going out more to the left, to the left, to the left. So it's going to eventually keep going left, 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 right? So if I'm starting all the way to the left, notice the graph is going up, 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 and it stops increasing when I get to x is 0. So the graph is increasing from x is negative infinity all the way to x is 0. So this is my interval notation where it's increasing in the y values from negative infinity for x to 0 for x. Then if I'm at x equals 0, notice the y values start to decrease. So it's decreasing from 0 all the way until I get down to here. This is where the y values stop to decreasing, and that is at an x value of 1.5. So notice I'm not naming the y value, I'm naming the x value. Then at 1.5, the y values start to increase. So I have another increasing interval from x is 1.5 all the way to where x equals 3, the y values are increasing. And then at x equals 3, the graph starts to decrease again. So it's decreasing from 3 all the way to the biggest x value ever, infinity. Notice there's no place in this graph that is constant. You won't always have one of each of these, and you won't always have just one. You could have multiple. Okay, for part B, looking at the graph, where is the graph increasing, decreasing, constant? We're starting on the left side. So notice this is flat here. This is constant from an x value of negative infinity all the way until you get to x equals negative 2. That's where the graph stops being constant. And then at x equals negative 2, the y values start to increase. So it's increasing from x is negative 2. Notice that there's a change in the graph here, but the y values are still increasing. You go all the way to where the y values stop increasing, which is at x equals 4. And then at 4, it becomes constant again. So it's constant from 4 all the way to infinity, since that's an arrow. At no point in this graph is the y values decreasing. Okay, you're up. Starting here, what is the interval in which the graph is increasing, decreasing, or constant on the left side? Okay, so it's increasing from an x value of negative 5 to negative 4. Then what is happening to the graph? Okay, it is being constant from an x value of negative 4 until negative 1. And then what's happening to the graph? Okay, at negative 1, it's now starting to decrease from negative 1 until you get to x equals 1. Now what's happening to the graph? Okay, so from here, it's now constant from x equals 1 until you get to x equals 3. Now what's happening to the graph? Okay, at 3, the y values are going up. So it's increasing from 3 all the way to, this is an arrow, so it goes to infinity. All right, for D, we have to graph this one. We have x cubed plus 2. Remember, this is an S-shaped graph, and it's shifted up 2. So instead of putting a dot at 0, 0, you go up 2. We're going to cube the numbers from this dot, so go right 1 cubed is 1. You can go right 2 cubed, that would be up 8, way up here. You go left 1 cubed is negative 1. Left 2 cubed would be down 8, which is down here. So draw in your S-shaped graph. So now we're going to say if this is increasing, decreasing, or constant. Start on the left side. Notice I'm going up, 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 up. It's increasing everywhere from negative infinity to infinity. All right, continuity. This is a separate topic. The definitions of continuity is to say that number 1, A is in the domain or f of A exists. The limit as x approaches A of f of A exists, so you can't have an undefined limit. And then the limit as x approaches A of f of x should equal f of A. So plugging in the A should give you f of A. There's 3 types of discontinuity. The first one's called jump discontinuity. Notice I always call this the tracing with my pencil test. So starting on the left side, if I'm tracing the graph with my pencil, I have to pick up my pencil here to go down here. So wherever you pick up the pencil is called discontinuity. Over here, if I'm tracing the graph, I have to hop over this open circle, so it is discontinuous here. And then if I'm tracing this graph, I would have to pick up my pencil to get over here past the asymptote. So whenever you have to pick up a pencil, it is considered discontinuous. So looking at the graph, this is determined for what numbers x, if any, the function is discontinuous. So if I'm starting to trace the graph on the left side, notice the first place I'd have to pick up my pencil is right here at x equals negative 3. Then I could go up here and I continue tracing. The next place I have to pick up my pencil would be at negative 1. And then at 1, and then at 3, and then at 5. So those are all the places you have to pick up your pencil. Over here, if I'm tracing the graph, where I have to pick up my pencil would be x equals 0. So I'm picking up my pencil so I can jump back over here to this part of the graph, hopping over the asymptote. All right, for C, starting on the left side, the first place I have to pick up my pencil is right here at x equals negative 1. And then the next place I have to pick it up would be here at x equals 3. And it should go on for good for then. All right, number 3 says to determine whether the graph is continuous at the given x value. So remember what we learned. We just plug this one value in here for x. And that's going to give me 3 times 1 squared is 3, plus 7 times 1 is 7, so 3 plus 7 is 10. This is a number, so this is continuous. I didn't get an error, so it should be good to go. For this one, if I plug in the 3 for x, I'm going to get 3 squared minus 3 minus 6 all over 3 minus 3. I'm going to simplify the top. I get 9 minus 3 minus 6, which is 0, over 3 minus 3, which is 0. You may remember you can't divide by 0. So in this case, this is an error. This is not going to have a solution. So this is discontinuous. Whenever you get an error, it's discontinuous. All right, number 4 says to graph the function and then determine whether the graph is continuous at the given x values. So this is a piecewise function. All right, we're going to start graphing this first equation. Notice it's a line. It has a y-intercept of 2 and a slope of 1. So starting at 2, slope is up 1 over 1, up 1 over 1. For the domain, it's an open or a solid circle at x equals 0, so this is going to stay solid. You're keeping the graph that is less than 0, so we're keeping this. Remember, you erase in the opposite direction. This is pointing left, so you're keeping left, so you're going to erase to the right. This is y equals 2, so that's a flat line through y equals 2. And then we have this would have been an open circle, but it's already solid from up here, so it's going to stay solid. And then this one is a solid circle at 1, keeping everything in between, erasing anything not in between. And then finally, we have our U-shaped graph, x squared, and it's shifted up 2. So instead of starting at 0, 0, you're going to go up 2, put a dot, and we're going to square the numbers. So right 1 squared is 1, fold it over the vertex, back to the original dot. Right 2 squared would be up 4, fold it over the vertex. There's my U-shaped graph. Looking at the domain, it's an open circle at x equals 1, so that would become an open circle. We're keeping where it's greater than 1, so keeping to the right of 1, erase in the opposite direction. So there's my graph. So to answer the questions, part A is saying, is it continuous at x equals 0? So as I trace this graph, do I have to pick up my pencil? The answer is I don't have to pick up my pencil, so it's continuous. But do I have to pick up my pencil at 1? Yes, I do. To jump that jump continuity, this would be considered discontinuous.